So I'm a theoretical physicist, so I do theoretical physics. And what is that? What do I do in my everyday life? I play. Theoretical physics is like a game. A game in which you're starting from some scattered information, some scattered experimental information, and from there you are trying to build a story. And the story is the story of the fundamental laws governing nature. And in order to build this story, you're using mathematics, because mathematics, we've learned, is a language of nature. So what we are trying to do is to infer from the experimental information those fundamental laws and express them in terms of mathematics. And then once we have constructed this theory, we're trying to understand what can be learned from that and compare it then with new experimental results and to see if they are true or not. So my working place is CERN, the Theoretical Physics Division, and in the last years I've concentrated on physics for the LHC. In particular, what are we learning from the discoveries made at the LHC? There was a long preparation. Essentially, my whole scientific career has been centered on the LHC. The LHC was a holy grail. We were all expecting the moment of revelation, of the epiphany, in which we understand how nature works. So it was very exciting for me to see the results coming, because that's a test of all the activity that I've done in my life. So in the last years, I've really concentrated on this, in particular on what is the information that we can obtain from the Higgs discovery. It was a really extremely exciting when the Higgs boson was discovered, because it was a confirmation of our ideas about how symmetries are realized in nature. It was a very important moment. Certainly it is one of the crucial steps in the history of science. Nevertheless, I have to confess that as a theoretical physicist, was also a little bit of a moment of disappointment, because we were expecting something more beyond just the Higgs boson. The Higgs boson accounts for the generation of mass and for the breaking of symmetries, but does not explain in depth most of the problems connected with this. So we were expecting to see new hints of something else that could give us the clue on how to construct more fundamental theories. And these clues did not arrive. What does that mean? Well, you know, this idea that we had that something new had to be discovered was based on our picture that we have of nature of layers, one after the other. It's like an onion, that you peel the onion and you always find an extra layer. We were expecting to find a new layer of physics, and we haven't seen it. So what can we conclude of this? Well, it could be that we've just been unlucky, that maybe in 2 years from now, when the LHC will start with new energy, we'll discover this new layer, and then we'll start from there. But it could also be, and that will be a surprise, that there's no next layer. So our view, our paradigm of how fundamental laws are built has to change. And this will be a really incredibly interesting revolution. You see that theoretical physics thrives on puzzles, on paradoxes, on things that we don't understand. So now that we are facing this crisis of the data that do not show any new results, it's a moment of crisis, but out of this crisis something new can appear. So we have visions on how we must maybe abandon many of the old ideas about the fundamental laws of nature and go towards a new vision. And right now I'm really studying to go to see what these new visions could be. Planck has a similar story to the LHC. I see it's an incredibly important experiment which has been a tremendous success from the technical point of view, but from the physics point of view has confirmed what we knew before. It's confirmed a picture of the universe that we had. This is a very important step, but it's not, as a theoretical physicist, what I want. I want to see some crisis. And this was not shown by Planck at this stage. Similarly then in the case of the LHC, also Planck will release new data next year, and this data may reveal a new reality, and we are eagerly waiting for that. For the moment, we have then to cope with this possibility that we have to change many of our basic paradigms on how the universe works.